Hello, guys. We are ready for some science. I'm excited to get into this new unit. It starts on page 335 in your science book. So go ahead and turn there with me, please. Pause the video if you don't have your science book and get your science book ready so you can follow along. Page 335 is where we're going to where we're going to begin, rather. Our essential question today is, how do the sun, earth, and moon interact? Now, we are moving away from kind of like animal life science, like we studied life cycles and food chains, food webs, all those different things we were looking at before Christmas. And we're moving into more earth science today. And for this unit, talking about the earth, not so much that things that live on it, but the earth itself. And so today, obviously, the earth, sun, and the moon. All right, flip on over to 336 and let's get started. How can it be morning where you live and nighttime in India at the same time? You cannot feel it, but Earth moves in space. Have you ever thought about that? I know one day in our Google Meet, Brooklyn said to me, I know what time it is in China. It was like 11 o'clock that night or something like that. It's the other side of the Earth. So when it's daytime here, it's nighttime on the other side of the Earth. Let's read about why. People once thought that the sun moved around the Earth. After all, the sun seems to rise, move across the sky, and set each day. Today we know what makes it seem like the sun moves around the Earth. Earth rotates or turns like a top. Earth rotates around an imaginary line called an axis. Earth's axis runs through it from the North Pole to the South Pole. Once every 24 hours or once a day, Earth rotates about its axis. So you can imagine the Earth, and when it rotates, it means it spins around like this. Just imagine sitting a ball and spinning it on a table, and it spins around and around like this. In one place, around an axis, the Earth is spinning around. Okay? Earth's rotation causes day and night. As it rotates, one side of the Earth faces the sun. This part of the Earth has daytime. The other side of the Earth faces away from the sun and has nighttime. As Earth rotation continues, parts of the Earth cycle between day and night. Each planet rotates at a different rate, so the length of day is different. For example, Venus rotates so slowly that one day on Venus is equal to 225 days on Earth. That's crazy. All right, so I've got my light kind of over here today if it looks a little different so we can look at some things. So let's pretend this big apple with a worm on it is the Earth. And let's pretend here's Mr. Helton's class on this side of the Earth right here. And this light right here is going to represent the sun. So the sun is over here, and here's the Earth. And as the Earth is facing the sun in this direction, where we are, where our class is, the sun is shining right on this side of the Earth. But look at the other side of the Earth here. It's dark, isn't it? So when one side of the Earth is day, the other side of the Earth is night. Now what happens as the Earth spins? Well, it gets later in the day and later in the day until we are in the dark and the other side of the Earth is in the night. So the other side of the Earth would have daytime, and here we are over here in the dark having nighttime. So as the Earth rotates like this or spins on its axis, the parts of the Earth move from day to night, day to night, day to night, over and over again, and that's what causes day and night. The Earth rotating on its axis. Now, don't forget that. So the sun is in one spot. The sun stays still. The Earth is rotating on its axis. It's not the sun moving. If you want to do a fun experiment while you're at home, on a sunny day near a window, in a room that has a big window at your house, and if you can find some sticky notes, make sure you get mom and dad's permission first. Starting at like 8 o'clock in the morning, even earlier if you want, put a sticky note wherever the sun is shining. Maybe at 8 o'clock in the morning, it's going to be pretty low in the sky, so it might be shining on the wall somewhere. But then the sun, as the earth rotates, it's going to look like the sun is moving, but it's really the earth moving. And so every hour, if you put a sticky note where the sun is shining at 8, check again at 9 and put a sticky note where the sun is shining at 9. It's going to be in a different spot in the room. And then at 10 and then 11, keep putting sticky notes where the sun is shining, and you'll see that the earth is rotating because the way the sun is shining into the room has moved. So that's a fun little easy experiment you can do at home with just some sticky notes. Try it sometime. All right, so we look here at this next page, 337. It's just showing what I showed you with my apple. Here's the earth. One side is going to be daytime. One side is going to be nighttime. The side that's facing the sun will have day. The side that's away from the sun will have night. As Earth rotates on its axis from west to east. As a result, the sun appears to rise in the east and set in the west. Okay. Turn to page 338. The Sun-Earth-Moon system. Earth is not alone in space. You can easily spot two other bodies in the sky, the sun and the moon. How do they all move together? The sun, earth, and the moon form a system in space. Excuse me, this system is held together by gravity. Gravity is a force that pulls objects toward each other. Gravity pulls Earth toward the sun, holding Earth in its orbit around it. An orbit is the path that an object takes around another object in space. Earth revolves. Now remember, we looked at the word rotates a minute ago. There's a difference here. We're going to look at it. Earth revolves or travels around the sun. It takes Earth about 365 days to complete one revolution. Okay. While Earth revolves around the sun, the moon revolves around the Earth. Earth gravity pulls on the moon. Like Earth, the moon also turns on its axis. It takes about a month for the moon to complete one rotation. During the same period of time, the moon makes one complete revolution around the Earth. As a result, the same side of the moon always faces the Earth. Okay, so let's take a look at our pretend Earth again here for a minute, okay? So when the Earth rotates, it's doing this. It's spinning on an axis. It's staying in one place, rotating, causing day and night. But not only does the Earth rotate, let's pretend for just a minute that my hand is the sun. The Earth, as it's rotating, is revolving around the sun on an orbit. So the Earth goes around the sun, and as it's going around the sun, as it's revolving, it's doing another R word, it's rotating and revolving. So it's spinning in two different ways at the same time. And then the moon is doing the same thing around the Earth. And so remember the difference between those two words, okay? This is rotate, and this is revolve, to go around something. Rotate, revolve, okay? You need to know the difference in those two. By the way, do you know how long it takes to rotate once, for the Earth to rotate once? That's one whole day. How many hours is one whole day? It's 24 hours, isn't it? So the Earth rotates on its axis one time in 24 hours. How long does it take for the Earth to revolve around the sun? Well, that's 1 year. So today is January the 4th, and let's pretend the Earth is right here. And the Earth will move, and it'll be back in the same spot again next January the 4th. Isn't that crazy? It takes 1 year for the Earth to go around the sun. All right, let's take a look at this right here. The sun, the moon, and Earth all have different characteristics. The sun has the largest diameter. That means it's the biggest of all the bodies in the solar system. An object's diameter is the distance from one side through its center to the other side. So let's look at this comparison chart here. The sun is made up of hot, glowing gases, mostly helium and hydrogen. Its diameter from one side to the other through the center is 1,391,000 kilometers, which is 864,327 miles. That's a big sun. It's estimated it's about 4.6 billion years old. The Earth It has rocky surfaces, large oceans, thick atmospheres of nitrogen and oxygen, has life forms like little fourth grade kids running around. It's very scary. The diameter, it's about 7,926 miles from one side to the other through the center, which is a lot smaller than the sun. Scientists estimate it's about 4.5 billion years old. The moon has a rocky surface, no atmosphere or liquid water. It's got extreme cold and heat, and there's no known life forms. The diameter, it's only about 2,159 miles, so it's even smaller than the Earth. And the scientists think it's about 4.5 billion years old. Okay, so as we look here at this diagram is showing what we just talked about with the apple. So the Earth is revolving around the sun, As it's revolving, it's rotating on its axis. The moon is revolving around the Earth, and it's also rotating on its axis so slowly that the same side of it is always facing the Earth. Ever heard a song called The Dark Side of the Moon? Yeah, the moon really does have a dark side, but that's never facing the Earth. How do they move? The arrows in the picture show the two types of movement that Earth makes in space. Label each arrow with the movement it shows, then explain how the Earth moves, okay? Well, this right here, this arrow is showing that the Earth is what? It's revolving around the sun. This arrow is showing that it's rotating on its axis. So, seasons, what? We're talking about the sun and moon and Earth. What in the world does that have to do with seasons? Well, it has everything to do with seasons. Let's talk about why. When it's summer in the United States, it's winter in Chile, which is down in South America. How can two places have a different season at the same time of the year? So think about this. I was listening to some Christmas music on the radio, and they were letting some people come on and talk about their favorite memories. And there was a lady who got on there who grew up in Brazil, which is the south of the equator. It's in the southern hemisphere. And she said, unlike the United States, where Christmas is in the wintertime, in Brazil, Christmas is in the summertime. And so they would have pool parties for Christmas. That sounds weird, doesn't it? But let's find out why one part of the earth has a season that's different than the other part of the earth. Earth rotates on its tilted axis. So, okay, it would not be straight up and down like this. Earth is not sitting straight up and down, but it's tilted. It's kind of, as it rotates, it's kind of tilted like this, okay? So, what's that going to change? As Earth revolves around the sun, the direction of its tilted axis doesn't change. The tilt of the Earth's axis and its orbits cause the seasons. Okay, so as the Earth is revolving around the sun, its tilt stays the same. It doesn't go tilt the other way, then tilt back this way. Its tilt is always like this. Okay? So it's always like this. I'll show you what I mean in a minute. Earth is divided into halves called hemispheres. The northern hemisphere extends from the equator to the North Pole. The southern hemisphere extends from the equator to the South Pole. In June, the northern hemisphere is tilted towards the sun and gets more direct rays of sunlight. It has more hours of daylight and warmer weather. It's summer there. In June, the southern hemisphere has the opposite season takes place. Why? The southern hemisphere is tilted away from the sun and gets less direct sunlight. It has fewer hours of daylight and cooler weather. It's winter there. In December, the northern hemisphere is tilted away from the sun. As a result, it's winter there. At the same time, the southern hemisphere is tilted toward the sun and has summer. Let me show you that because that's kind of confusing to think about. Oh, I'm dark now, aren't I? So let my light here be the sun. That's a bright sun, isn't it? It's going to be too big. Let me back off a little bit. All right, here's the Earth, okay? So let's say the Earth is tilted like this, and look at the little face of the worm there, okay? So the Earth is tilted like this, and if this light is the sun, the little face there you can see is tilted away from the sun. So it would be winter where the little face is. Let's say that's Tennessee. It would be winter there. But as the earth spins, remember, its tilt is the same way. And so it gets to the other side of the earth, the other side of the sun, rather. Now that caterpillar is tilted towards the sun. So now it's going to be summer in Tennessee. And then as it moves on around, it's tilted away from the sun again. So it's going to be winter. And then halfway is like spring, summer, fall, winter. So because the earth is tilted, it's either tilted towards the sun sometimes, or it's tilted away from the sun at other times. And that is what causes the seasons. The earth being tilted toward the sun or away from the sun as it revolves around the sun. And so the top part of the earth, the top half of the earth, is called the northern hemisphere. The bottom half of the earth is called the southern hemisphere. So look at this, when the northern hemisphere is tilted away, the southern hemisphere is tilted towards winter, summer. And then when it's on the other side of the sun, it would be summer, winter, because it would be the opposite way. Whichever side of the earth, the northern hemisphere or the southern hemisphere, is tilted toward the sun, that side will have summer. When it's tilted away, that side will have winter. Just you have to kind of envision that in your head. Okay, let's go to the next page. And this just shows in a diagram what I was just showing you with my apple. Okay, so seasons in the northern hemisphere. When the northern hemisphere is tilted away from the sun, that part of the earth has winter. When the northern hemisphere is tilted toward the sun, it just has summer. The closer you are to the sun, the warmer it's going to be, right? So if we look here in summer, this top part of the earth, the northern hemisphere, it's tilted towards the sun. It's like it's leaning towards the sun, you ever lean towards the fireplace or put your feet up near the fireplace so you can feel the warmth more? Yeah, well, the earth is tilted. It's kind of leaning towards the sun, and it's warmer in the northern hemisphere. Okay, as it moves on, it starts tilting away from the sun a little bit, and the temperatures start getting cooler, and we have fall. And then when it's on the opposite side of its revolution around the sun, it's tilted away. The top part's tilted away from the sun, like it's going to be like it was on December 21st. It would have been right here, and it starts winter. And then it starts tilting back towards the sun slowly and starts warming up in the spring until it's all the way tilted toward the sun. And then it's summer again, and then it starts tilting away from the sun, and you get the idea, right? So that's what causes seasons. The tilt of the earth and where it is in its revolution around the sun. That's a lot to take in. But just remember, the closer you are to a fireplace, the warmer you're going to be, right? If you lean in close to that fireplace, you're going to be warmer. If you lean away from it, you're going to be cooler. So when the earth is leaning towards the sun, tilted towards the sun, it's warmer. So it's summertime. Our place in space. At one time, people thought Earth was the center of the universe. How did we learn this isn't true? Long ago, astronomers believed Earth was the center of the universe. Daily observations seemed to confirm this belief. When people looked at the sky, they saw the sun, moon, planets, and stars in motion. Naturally, they concluded that Earth was at the center of the universe. It took hundreds of years, new technology, and new observations for this idea to change. In the 1500s, a Polish astronomer named Nicholas Copernicus designed a new model or system of the universe. Based on new observations about the motion of the planets, he suggested that Earth and the planets revolved around the sun. Then in the 1600s, scientists gathered more evidence to support this sun-centered model of a solar system. Using a telescope he made, Galileo Galilei was the first to see moons orbiting Jupiter. His observation showed that all of the objects in space did not orbit Earth. Around this time, Johannes Kepler correctly described the shape of the planets' orbits around the sun. His calculations showed that the planets revolved around the sun in elliptical orbits. All of these scientists' observations changed our idea about Earth's place in space. So we're not the center of the universe. We're just one of the planets rotating around the sun. When people measure time using sundials, the changing shadow cast by the sun seemed to confirm that the sun revolved around the earth. We now know that the sun doesn't revolve around the earth. Earth revolves around the sun. Galileo was the first to study the night sky using a telescope. His observations helped support the sun-centered model of the solar system. The pictures here show a replica of Galileo's telescope and Jupiter and 4 of its moons. Telescopes showed us that we were revolving around the sun. All right, so we had a lot of information in today's lesson. I encourage you to go through here and let's take a look at a couple of these, see what you need to do. Change the part of the summary in blue to make the sentence correct. Day and night are caused by Earth's revolution around the sun. And no, it's rotation on its axis. Day and night, remember, revolution is going around something. That doesn't cause day and night. Earth has day and night because it rotates on its axis. Okay. Number 2, the discovery of moons around Jupiter proved that all objects in space revolve around Jupiter? No. All objects in space revolve around the sun, not the earth. Earth's seasons are caused by the Earth's revolution and rotation in space. Well, it's got to do with a revolution around the sun, but not its rotation. It's the revolution and its what? Its tilted axis. Because sometimes it's tilted toward the sun and sometimes it's tilted away. During winter in the northern hemisphere, there are more hours of daylight and it's warmer. Well, now we know that's just dumb, isn't it? It's winter right now. Is there more daylight and it's warmer? No. There's fewer hours of daylight and it's colder. I don't like it getting dark at 5:30 every day, do you? I'm ready for a little more sunlight. When it's spring in the northern hemisphere, the season is summer in the southern hemisphere. No, they're going to be opposite. So if it's spring in the northern, it's going to be fall in the southern. So it'd be just the opposite. Spring and fall would be opposites, and then winter and summer would be opposites. The sun-earth-moon system is held together by the revolution of the earth and the sun. No, it's held together. What's holding it together? What's the glue that keeps everything together? Gravity and attracting the objects toward one another. I'm not going to go over these because this is going to be your assignment for today. These words that we've talked about, we'll go over them one more time. A model is just kind of like an example of something. Revolve, remember revolve means to go around something. Orbit, it's the path the planet takes around the sun. Hemisphere is half of the earth. An axis is an imaginary line that goes through the center of the earth. Gravity holds things together. Hold your feet to the ground. Rotate, remember rotate is like spinning in one place, like a top spinning. And then season, it's caused by the tilt of the sun, tilt of the earth rather towards the sun or away from the sun. All right, if you'd like to go through these pages in your book and follow those directions, I think it would help you understand today's lesson even better. Okay. And then we'll get into another lesson tomorrow to kind of review what we talked about today. Do your assignment. Make sure if you'll go ahead and do this page in your book, you'll have all the answers, okay? The clues are going to be these, and then you've got to match the word to these clues. So it should be an easy 100 if you go ahead and do this first. All right, more about all this tomorrow.